So 9.3, we have a new shape that we're going to talk about, which is hyperbolas. Hyperbolas are super similar to ellipses. They just have one difference, but the graphs look totally different. So a hyperbola is kind of like two mirrored parabolas. It says a hyperbola is the set of all points x and y in a plane, the difference of whose distance from two distinct points, the foci, is a positive constant. A couple of things that we have for our hyperbolas. Again, they look like two mirrored parabolas. We're going to have two of them. We'll have two foci inside of each of the parts of the hyperbola. And then we'll also have a transverse axis that goes through the foci, which we'll talk about more on the next page too. The graph of a hyperbola has two disconnected parts called the branches. The line through the two foci intersects the hyperbola at 2 points called the vertices. So we'll have a vertex in each part of our branch. The line segment connecting the vertices is the transverse axis. That's what I drew on the last page, but it'll connect the vertices and the foci. This is our transverse axis. And the midpoint of the transverse axis is the center of the hyperbola. So we'll also have a center, which is just going to be the midpoint of, it'll be the midpoint of the vertices. It'll also be the midpoint of the foci. So our foci are here. So if we look here, A is the distance from the center to the vertex. C is the distance from the center to the foci. B isn't really on our graph, but we'll talk about it more in the next couple pages. So we have a standard form of our hyperbola with a center at 0, 0. The standard form of the equation of our hyperbola depends on whether the hyperbola's transverse axis is horizontal or vertical. Here, one difference between hyperbolas and ellipses that we did in the last section is A is always first. Before A was always the bigger number, here A is always first. And then our formula to find C also changes. Our formula to find C is now C squared equals A squared plus B squared. So before it was a minus, now it's plus. Which that brings us to our actual equations for hyperbolas. It's the same as an ellipse, but it has a minus in the middle. So our horizontal ellipse, the x squared is going to be first. Our horizontal ellipse, the transverse axis is horizontal. So in a horizontal ellipse, the transverse axis is horizontal. So our ellipses are sideways. In a vertical ellipse, the y is first, and our transverse axis is vertical, which means our ellipses would be vertical like this. So I said on the last page, A is the distance from the center to the vertex. C is the distance from the center to the foci. B is the distance from the center to the co-vertices, but notice how our co-vertices aren't really on our hyperbolas. we're also going to have asymptotes here. So these dotted lines are asymptotes. We'll have equations for our asymptotes on the next page, but one way that we can help draw our asymptotes is if we connect the vertices and the covertices with a box. So notice how we have this box here. If we go through the corner of the box and through the center, back through the other corner, that would be our line for our asymptote. So if we go through the corner of the box, through the center, and through the other corner, that's our line for our asymptote. So the covertices really just help us draw our asymptotes. On the next page, we have our formulas for the asymptotes, depending if we have a horizontal ellipse or vertical ellipse, meaning a horizontal transverse axis or vertical transverse axis, we have a different formula. So horizontal, our formula is y equals plus or minus b over a times x. Where if it's vertical, our formula is y equals plus or minus a over b times x. And this is when our center is at 0, 0. So the difference between these two equations is if it's b over a or a over b. So vertical is a over b. So at number 1, we want to find the center, vertices, foci, and asymptotes, and graph it. So similar to our ellipses, this has to be equal to 1 before we can start finding everything. So what would I need to do to make this equal to 1? Divide everything by 16. Perfect. So we get 1 over 4, or x squared over 4, minus y squared over 16 equals 1. Now, because x comes first, we know it's going to be a horizontal transverse axis. So my vertices and my foci are going to be horizontal. So my ellipses are going to look like this. And then also remember, a always comes first here. So this is going to be our a squared. 4 is our a squared. And 16 is our b squared. So for hyperbolas, a always comes first. So a would be 2, b would be 4. How do I find c? Awesome. C squared equals a squared plus b squared. So c squared equals a squared, which is 4, plus b squared, which is 16. So c squared equals 20. Take the square root. C would equal, when we simplify this, our factors are 4 and 5. So you would get 2 square root 5. Which, to help us graph, we can just estimate from our original square root. So square root 20 is about, we would say, it's a little bit less than 5 because it's just below square root 25. So I could call it 4.5-ish. So let's graph it, and then that'll help us find everything. Also, where is our center? 0, 0. We're not adding anything to the x or the y, so our center is just 0, 0. So I'm going to put a point at my center, 0, 0. A is going to be the distance from my center to my vertices. So I'm going to go to the right 2 and to the left 2. Because A is under the x, we move along the x, so to the left and right, but we also knew that it was going to be a horizontal transverse axis, so our vertices are going to be horizontal. So for my vertices, we can label those as -2, 0, and 2, 0. Next, we could do our covertices. So B helps us with the covertices. So I'm going to go up 4 and down 4. So my covertices would be 0, 4, and 0, -4. I'm going to save my foci for last. From here, I'm going to draw my imaginary box, I'm going to call it. It's not really there, but it's an imaginary box that we make with our vertices. And then in the corner of the box, goes through the center, through the other corner. This is going to be my asymptote. I'm going to do the same thing with the other diagonal. So through the corner of the box, through the center, and through the other corner, this is my other asymptote. When I draw my hyperbolas, they're going to kind of hug the asymptote. So it's just going to go right in the corner there. So it'll go through the vertices, kind of hug the corner of the asymptotes. Next, let's find our foci. So our foci, we go from the center. They're going to be on our transverse axis, so they go left and right. And we said we go about 4.5-ish was that 2 square root 5. So I'm going to go to the right, 4.5-ish. It's about there. And to the left, 4.5-ish. So there's our foci. So our foci would be plus or minus 2 square root 5, 0. Because it moved on the x, so we add and subtract that to the x. Last thing we're going to find is our equation for our asymptotes. So drawing the asymptotes is the easy part because it just goes on the diagonal of the box. But for our equation, we need our formula. So for our asymptotes, our formula is y equals plus or minus. Now here's the tricky part. Because it's a horizontal transverse axis, horizontal is b over a times x. So y equals plus or minus, our b is 4 over a, which is 2 times x. So y equals plus or minus 2x. So this would be our equation for the asymptotes. So in example 2, we're finding the same thing, center, vertices, foci, and asymptotes, and graph it. What would I have to do first here? Awesome, we want to divide everything by 100 because it has to be equal to 1. So 25 goes into 104 times. We have y squared over 4 minus 4 goes into 125 times. So x squared over 25 is equal to 1. So because y comes first now, because that's our positive one here, y comes first, it's going to be a vertical transverse axis. So our hyperbolas are going to be vertical like this. And where's our center? 0, 0, perfect. We're not adding anything to the x and y's yet. So I can draw my hyperbola here. Put my center at 0, 0. Next, let's figure out what A, B, and C are. So remember, A always comes first with our hyperbolas. So if 4 is A squared, what is just A? 2. And if 25 is B squared, what is just B? 5. Perfect. And how would we find C? A squared plus B squared. Awesome. So C squared equals 4 plus 25. So C squared equals 29. Take the square root. Can't simplify the square root of 29, so we can just leave it as square root 29. But let's approximate it to help us with graphing. So square root 29 is just a little bit more than square root 25. So this would be about 5-ish. So we could call it 5.5 if you want. It's going to be a little bit more than 5. So let's put our vertices on the graph. So A tells us our vertices. Which direction do I go to? Up and down or left or right? Up and down. We go up and down 2 because our transverse axis is vertical. So for my vertices, I go up and down. Also, 2 came from under the Y, so we're going to move up and down because Y goes up and down. So I go up 2, down 2. These are my vertices. So 0, 2, and 0, negative 2. Next, we can do our co-vertices. So B tells us our co-vertices. We're going to go left and right for the co-vertices. So I'm going to go to the right 5 and to the left 5. So our co-vertices would be 5, 0, and negative 5, 0. Now our co-vertices just help us with our asymptotes. It tells us how big our box is going to be. I'm going to draw my box with the vertices. And then my asymptotes are going to go through the diagonals of the box. These are asymptotes, which means that I can draw my hyperbola. It just hugs the asymptotes. So it'll look like this. And it goes through the vertice. Next, we can plot our foci. Which direction would I put the foci? Up and down or left or right? Up and down. I'm going to go up 5.5-ish. Yes. But the actual number that is square root 29. So for my vertices, I stayed at 0 and went up and down square root 29. And then lastly, let's just come up with our equation for the asymptotes. So because we have a vertical transverse axis, our asymptote formula is going to go A over B. So it's y equals plus or minus A over B times x. So y equals plus or minus 2 over 5x. This would be our asymptote equation. Next, we're going to do the same thing, but we have a shifted center in our hyperbolas. So just like we were doing with ellipses and parabolas, what we add to the x is going to be our h. What we add to the y is going to be our k, but don't forget we changed the sign of the h and the k. And then if the y comes first, the k is still paired with the y. So our center is always going to be h comma k. So even if the y comes first, k is still paired with the y. So that number that we add or subtract to the y is going to be in the y spot of our center. This also changes our equations for our asymptotes. So we have y equals k plus or minus. Same thing if it's a horizontal transverse axis, it's b over a times x minus h. And then the other one, if it's a vertical transverse axis, it would be a over b. So k plus or minus a over b times x minus h. So number 3, it's equal to 1, so we don't have to do anything to start. Since y comes first, is it going to be a horizontal transverse axis or a vertical transverse axis? Vertical. So I'm going to draw that just so I remember that it's going to be vertical, and my hyperbolas are going to be vertical. The first number is going to be our a squared. Second number is our b squared. So if a squared is 9, what is a? 3. And if b squared is 4, what is b? 2. How do we find c? A squared plus b squared. So c squared equals a squared plus b squared. C squared equals 9 plus 4. So c squared would equal 13. Take the square root. So c is the square root of 13. We can't simplify the square root of 13. Let's approximate it so we know where it's going to go on our graph. Square root 13 is close to the square root of 16. It's a little bit less. Square root of 16 would be 4. So it's going to be less than 4. So we could call it like 3.5-ish. Remember, there's really no difference in 3.3, 3.5, 3.7. Just as long as you know it's going to be a little bit less than 4. So let's graph. What's our center here? Awesome. -3, -2. Perfect, because the x or the h is with the x. So let's graph our center. So we're going to go to the left 3 and down 2. So there's our center for our hyperbola. Next, let's put our vertices. So A tells us where our vertices are going to be. Which way would I go to put my vertices? Up and down or left or right? Up and down. So I'm going to go up 3 and down 3. So let's label everything here. Our vertices are going to be -3, 1 and -5. Oh, -3, -5. So you could always just look at your graph and see where did I put them, or since it was being added to the y, we would just add and subtract 3 from the y, from our center. Next, let's put our co-vertices. So we're going to go to the left and the right 2. So our co-vertices would be -1, -2, and -5, -2. So because we are moving to the left and right for our b, and b is under the x, we would add and subtract 2 from the x. So now that I have my vertices, I can draw my little imaginary box there. And then we can put our asymptotes. So my asymptotes are going to go through the center and the corners of the box. It's going to be the diagonal of the box. Which way would our hyperbolas go? Up and down or left or right? It would go up and down. Perfect, because we said it was going to be a vertical. We drew that in the beginning. It's going to be vertical parabolas, hyperbolas, sorry. Let's put our foci on there now. Which way would our foci go? Up and down or left or right? Up and down. They go inside of our hyperbolas. So we're going to go from the center up 3.5. It's about there. And from the center down 3.5. So I add and subtract. Since I added it and went up and down, I'm going to add and subtract it from the y. So we have -3, comma, -2 plus or minus square root 13. The very last thing that we have to do here is write our equation for our asymptotes. Since this is a vertical transverse axis here, it's going to be a over b. So we have y is equal to k plus or minus a over b times x minus h. So y is equal to k comes from our center. So -2 plus or minus a is 3 over b is 2 times x minus h. So x plus 3. So this is our equation for our asymptote. So 4 looks a little bit funky because I don't have a denominator under the x, but what could I call the denominator under the x? 1, perfect. It's not really written there, but it would be 1. So we can start with our center. What would our center be? Three comma 2, perfect. We can graph that. I'm going to go to the right 3 and up 2. And then let's figure out our A, B, and C. Which one comes first? What would 1 be? That would be our a squared. Perfect. A always comes first for our hyperbolas. So a squared is 1, b squared is 9. So that means a is 1 and b is 3. We have to do our a squared plus b squared to find c squared. So a squared would be 1 plus b squared is 9. So c squared equals 10. Take the square root. C would be the square root of 10. We can't simplify the square root of 10, but let's approximate it so we know where to put our foci. Square root of 10 is just a little bit more than the square root of 9. So we could call this 3.1-ish. If you wanted to call it 3.5, doesn't really matter. We just know that it's going to be a little bit more than 3. So let's put our vertices. What tells me how far I go for my vertices? A. And because I didn't do this in the beginning, but because x went first, do I have a horizontal transverse axis or a vertical transverse axis? Horizontal transverse axis. So I know that my hyperbolas are going to go horizontal. So I'm going to go to the left and right 1. So my vertices are going to be 2, 2 and 4, 2. So I just add and subtracted 1 from my x in my center. For the co-vertices, B tells us how far our co-vertices are, so we're going to go up and down 3, or I'm going to add and subtract 3 from the y in my center. So I have 3, 5 and 3, -1. So I go up 3 and down 3. Then I can draw the imaginary box here to help us graph. So my asymptotes are going to go through the diagonal and through the diagonal. And then our actual hyperbola is going to go which way? Up and down or left or right? Left and right. So it's going to hug the asymptote there and hug the asymptote there. So here is our hyperbola. Next, let's put our foci. So we go from the center a little bit more than 3. So from the center, I'm going to go to the left and right a little bit more than 3. So 1, 2, 3, be about there. And then from the center a little bit more than 3. 1, 2, 3. So there would be our foci. So because I went to the left and right, I'm going to add and subtract square root 10 from the x. So we have 3 plus or minus square root 10, comma 2. And the very last thing we have to write is our equation for the asymptotes. So our equation for the asymptotes is going to be y equals k plus or minus, since it is a horizontal transverse axis here, our equation would go a over b or b over a? B over a, perfect. B over a times x minus h. So y equals, our k comes from our center, so 2 plus or minus b over a would be 3 over 1, or just 3, times x minus h, which h is also 3, so x minus 3. So this would be our equation for our asymptotes.